All right, let's kick off. A lover of all things software development, Wade has worked in various product development and consulting roles throughout his career. He helps maintain two popular open source repositories, Poco and Awesome.net. Please welcome Wade to share his insights into building typesafe web forms.
All right. Cool, it's working. Thanks, Wes, for that nice introduction. And yes, I'm building typesafe web forms. And to do that, I'll be using a mix of technologies, namely Remix, Remix Validated Form, Zod, Tailwind, and of course TypeScript. Don't worry if you don't know any of these libraries. I'll cover what they do and in good time. First off, let's just pause and just take a look at the sponsors that have made today possible. Obviously, DDDs around Australia are volunteer-driven and mostly paid for by sponsors, hence why the tickets are affordable. And that's the whole point of them. It's an affordable conference. So I'm more than happy to put a sponsor slide up because all these sponsors, and there's a million in Perth, have made it possible today. And don't forget to check out the booths. There's some pretty cool merch as well you can grab. And I know MakerX merch, I know I'm plugging myself in, I apologise for that. But I know there's still some good merch there because I wanted to take some, but because I'm from Brisbane, I'm limited by the flight capacity. So what's my mission today? Well, when I got accepted to do this talk, and I was very humbled by people selecting it because there was so many great talks available. And when I got selected to do the talk, I went, right, well, first thing I need to do is put some goals down. And I thought, what do I want when I'm in the audience? And a good talk, right? So goal one, good talk. Now, if you know me and if you've worked with me, you know fairly average humour is just part of the package. And that's why it's there. So that's my mission, a good talk and demonstration of what fairly average humour is. And so who am I? Well, I'm Wade, and here is my family. There's Snowy, he's the newest addition. He's a spoodle, very picky about food, except if it's poo. We've got Bob in the middle. Bob is a very cuddly cat. He's a Manx breed. If you don't know them, they have the short tail, and he's a beautiful cat. And there's Bear. Bear is a look, but do not touch. But if you're me, you can pat him with your foot, but it's probably going to take you about 6 years to build up to that. And of course, my family, my lovely wife, Patricia, and my daughter, Leah. And a little bit of my artwork there, you've noticed. I'm just, putting it out there. I've got some feedback, and most people have said it's pretty good. I can't give you their names because I've forgotten it. But that is the feedback. And so, who am I? What drives me? Well, I like to build things, and I build things at MakerX, who helps other startups and ventures build and builds other startup and ventures. Or, because I'm from Brisbane, you might say the 4B, because there's a lot of builds in there, 4. So no AI used to change this image, by the way. Just got out on the way to the airport and took a snap. So yeah, look, I get this a lot, and the artwork is for sale. And I am accepting offers over 1 million, but for this month only, 20% discount. And if you're wondering, well, what would Wade do with all that money? I like the finer things in life, like shopping at Coles and Woolies. I also write blog posts. And so if you like this content and you like more, then there's some historical stuff. The best way to get notified about that is just to follow me on LinkedIn. Now, I know not everybody has LinkedIn or likes to use it. That's cool. There's also the MakerX blog site. You can subscribe, email notifications, all that sort of stuff. And for those who are sitting on the fence saying, champ, wait till the end. Let's just wait and see how this talk is. I'll show it again. So don't worry. I've covered that. It's fine. So, my talk. My talk is split into 3 parts. It is an adaptation of a blog series I did about 1.5 years ago. And in that blog series, I was talking about doing multi-action handlers in Remix, which is essentially just the same Remix route having multiple actions that do various things, rather than having multiple routes for those actions. And so part of that was making the forms type safe. So what I thought is, let's just twist this blog content a little bit, and I'll talk about the type safety of the forms in there. Each part builds on the next part, and we go from a good to better, best solution. And I'd like you to think of this as more of a pattern and not a library. I do use libraries, sure, but as you know, in web development, it's rare that there's only one library that does the same thing. There's always a choice, and there's always pros and cons. And so what I build today, I like to consider more of a pattern. And it's a pattern that I've used within MakerX on projects using other form libraries and alike. So don't get caught up on we don't use Zod or anything, because if you're using a Zod equivalent, it probably applies. The plumbing might change a little bit depending on the API surface. So in the first part, I define the problem, and what I do is I build a very basic to-do application, just using Remix and the fundamentals of the web. And it'll be functional, but it'll be fragile. So if we change things, I can't be assured or confident that it hasn't broken something without sort of running through all the features and seeing if they work again. So to partly solve that, in part 2, I'll introduce Remix validated form and Zod. And that will give me this, it'll still be functional, but it'll be slightly less fragile to change. And in part 3, I'll introduce hooks, proxy, and a dispatcher. And what that will give me is functional and what I call refactorable. So I'll just take a little side step at that point and talk about refactoring. Because on one hand, in a strongly typed language, refactoring is a very smooth experience, and when you do refactor in a strongly typed language, you have a lot of confidence that those refactors apply all through the code base. Whether you're in C#, Java, all those, even when you're refactoring and references are stored in text, there's usually a pretty unique pattern to those, and the IDEs that support the more advanced refactorings will pick that up and do those refactorings for you. So on one hand, we've got strongly typed languages are very good at refactoring, but they're strongly typed. Right on the other edge, where JavaScript lives along with languages like PHP, although my PHP knowledge is a little bit dated, you've got dynamic languages, and generally these suffer the worst when we're talking in terms of refactoring, particularly JavaScript, because it is just so flexible that it's hard to know how to refactor something unless the app is running, because there's so many points in which the information's lost. And if you're doing static analysis, it just goes, I can refactor that within this function. Outside that, all bets are lost, etc. And so what I like to do with TypeScript is find a line where I know my refactor experience is not going to be as good as refactoring in a strongly typed language, but I will have my type safety to the point where after I refactor, I will get type errors to tell me, hey, the solution's still not valid. And when the type errors go away, I'm back to a valid solution. Now, I might have to do 1, 2 refactors, but TypeScript's got my back, and I can be confident, like I could be in a strongly typed language, that those refactorings apply. So when I mention refactorable, I'm not saying, hey, it's as good as a strongly typed language. All I'm saying is I can refactor it with the confidence that I have enjoyed when using strongly typed languages, because, follow the red squiggles, right? And so if we look at the future of form libraries and type safety, I just want to point out I was playing around with React hook form, and the type safety in that is really good in version 7. I didn't play around with it enough to do a very componentized app where you might want your components holding the validation logic and all that, which this pattern supports. But it's looking a lot better, and I think we're heading down this path now where this talk will be irrelevant in a few years because we'll just have all that type safety out of the box. The other thing is Remix Validated Form has gone through a name change. They are now RVF. And the reason for that is they've dropped Remix as the #1 dependency. And so they just went, let's just call ourselves RVF, and you can use it with any React project. I updated all the source code for this talk, but I didn't make that change because there's enough of an API surface change that it would mean I'd have to restructure a fair bit of code. So just keep that in mind. And yeah, sorry, lost my way for a bit there. Okay, so let's get into it. All right, the problem. This is a pretty standard Remix project. Hopefully you can see that. There are some screens on the side, and I think I can probably zoom in a little more. If is that better? Yeah, okay, cool. Now, this is a standard remix project. I have got a few things, and I'm not going to cover them too much detail because I don't think we'll have enough time, but of course I've got some components. I've gone with the atomic design system for those components. They're very basic, button, panels, title. And the reason why I have done that is because the to-do application is styled. I'll show you that in a second. Got a context just so I know when things are loading, so I can apply that front-end spinner to let my users know that things are happening. Got a few hooks that just do a bit of heavy lifting, focus. I'm pretty sure every React project probably has, in some form, these. Something to help me focus, something to help me reset a form, and a nice little helper to use that context so I don't even really have to think about it. I've got some icons. I'm not going to show you them, but they're just React SVGs. Styles is a single background for the glass effect, and I'm using Tailwind, so you will see styles plastered everywhere in the React code. That may drive some people mad. Doesn't bother me. And just a few little helpers. This is one I'll talk about. So the database in this sample application is a shim. It's a mock, and it's pretty basic. It's, if you're thinking, it looks a little bit like repository pattern, yeah, basically. So we can mostly ignore that. And of course, being a remix app, I have a route. I like to call them pages, but they're technically not. It's a route. Cool. So simple to do. Let's just fire up this. Let's have a look at simple to do. This is simple to do. It's a to-do application that you would have seen 1,000,001 times. It has a few features that you might not have seen, like this cool reset button, and that just resets the state. So if you're playing around and you're like, oh, I'd like to delete that to-do item again, yeah, the reset button's there for you. You can delete a to-do item. You can, of course, edit one, and we might try bath the cat. We all know that's not going to end well. And of course, we can complete one and add one. Give DDD perf doc. Pretty basic. That's the application that the 3 parts will build and upgrade as we go. All of this source code is on GitHub. All of this source code is also on StatBlitz. It's linked. So if you just want to play around with some of these things but not pull down the source, StatBlitz is your friend. You can VS Code style editor and IDE, command line all in the web browser. And the best way to get a hold of that is MakerX blog. Just find the blog series and it'll have all the links there. Cool. So simple to do. Close this. All right, so let's go back to this route. We can get rid of the project structure. And we'll just, the first part will be a bit longer than the other parts because I just really want to explain Remix and how this works. And I know there's probably some people out in the audience that understand Remix, but there might not be. So I'll just quickly run through that. And thankfully, Remix is a really simple we can do that. It's not going to be any problem. The first thing I export is the meta. Meta is just a way of changing the title, all that sort of stuff. It's pretty boring, but it's also a problem in typical React apps that you're like, oh, should be so easy, right? But it can be hard. Next, I export a loader. A loader in Remix is what runs to pull data. It runs server-side. That data will end up client-side. It's pretty simple. Remix is built on the fundamentals of the web. So anything that's essentially not a get, an HTTP verb get, will run through a loader. So you can think, sorry, an action. A loader is the get. So anything that's a get will run through the loader. And it's essentially fetching the data. The action is the opposite. The action handles all the other HTTP verbs. Let's face it, it's probably just going to be post. And that is how we mutate the data, or we do a thing. So as you can see in the loader here, I grab the DB, I filter out the completed and the deleted, and I return that. And if we look at the action, I come in, there's a little bit of a random delay because I want people to be able to see the cool spinner when they're playing around with it. Very important to me that that spinner works. We get some form data. We split off using destructuring the action that we want to perform and the other values. The problem though here is these aren't really typed. When we go object.form entries, we'll see that we get back essentially a JS object that is a property map. The properties may or may not exist. It's not very type safe. But if we switch on the action, then we can do the intended action like reset the DB, we can delete an entry, we can complete, I've obviously optimized, add and edit into an upsert, and I do a little bit of validation. And this validation is happening server-side. And for the first version, I didn't bother doing any client-side validation because Zod and Remix validated form will do all that heavy lifting for me later. I've defined a to-do type, and what I tend to do in my Remix apps is I will just use the type of the loader. There's a little bit of TypeScript stuff here to unwrap everything. Like I get the type of the loader, I then isolate the return type, and then I unwrap the promise, and that gives me the to-do. Now, I could actually use the to-do type from the database, but the reason why I tend to use this type of pattern is inevitably the data we load is going to get more and more. As we build out our application or that part of the application, or we come back to maintain it later, there's going to be, at some point in the future, we're going to be returning more data. And so what that allows me to do is just concentrate on the loader, concentrate on the data, then my type will change and I'll get type errors afterwards. And so that's where I can go through and fix that all up. The other problem is, it's all right. It's all good. It's just a numbers game. No, don't worry about it. It's a numbers game. I don't even know my phone's on silent, to be honest. Nobody call it. Yeah, so that's why I use this pattern, and it does give me a disconnect between that database type and the front end type, and that can be sometimes you might see that as not being advantageous, but I see it as being a great division because inevitably when I come along and I load more data, I don't have to fiddle with types. It's all there, ready to go. It's just going to adjust itself. The last thing I export in the Remix route is the component. This is the React part. This is the bit that will run client-side, mostly. I'm not going to get into the specifics, but you can think of it as running client-side. And to do that, once we're in the component, if I want to fetch data from the loader or from the action, there's two hooks that Remix supplies. The first is the use loader data, which gives me the data from the loader, and that'll be my to-dos. The second is the data from the action, use action data. And in this case, the only data I'm turning from my actions is validation errors. So I just wire those into an error box. And I can show you that, if I can work out. You can see my server-side validation there, it just pops up the top. And that is because the data is coming back from the action. The other thing I have in my sample application is I hold state just so I know which to-do item I am editing. I also have a form ref, I've got my focus, a couple of use effects. I'm not going to go through these. These are just wiring up, making the UI work. And of course my loading context so I can have that spinner. I have one more hook here, which is useSubmit. That is from Remix. And that allows you to submit a form programmatically. And as I move down, you'll see here's all the Tailwind stuff. Here's my action result where I just put that in that red box. I have a form, and that is a Remix form item. And the rest is pretty much just my own TSX stuff and my own components. So as you see here, I've got my glass button. It is just a button with styling already placed on it. What you'll notice though is it's just a submit button. I've got a name for the value of that submit. And so I'm not doing anything that you might see in a traditional React app where I'm running some form of callback, which then initiates some server. I'm just letting Remix take this all. And that's why Remix is built on the fundamentals of the web. It's just using what we used to use before we had all these fancy frameworks just to do all that traffic. Moving on, I render out all the to-dos, and you'll see again, they will be rendered in a form. I have, again, buttons. I do have a checkbox somewhere here, which works a little bit differently, because obviously a checkbox can't also be a submit. So that one, I do have to wire it up client side with JS. Did I get it wrong? No? All good. If I get it wrong, I wouldn't be surprised. Just my understanding. So, and the last but not least is the edit area where obviously if we're not editing, we're adding. If we're editing, we're editing. And again, it's just a form, wiring that up with submits, putting in my action for the upserts. And the reason why I'm doing this is just so I can have all my actions handled in that one route, which I find a little bit more maintainable than having a route per action, which is the other way you can handle that in Remix if you don't want to jump through. If you just want an action handler and handling one action, you would do per route. I like to put it all in the same route because, if you're working on that nicely, just working in one file is fine. If it gets too long, it probably means you need to split it up rather than it's being in the wrong pattern. Okay, so what is the problem here? Well, the problem is, if you haven't picked it up, is we're using strings for everything. And if I change a string, I won't get any form of feedback until I run the application. So if I had actions here, my upsert would no longer work. If I change my upsert to upserts, it would no longer work. Everything on this page currently is by convention. And while I'm 100% compliant with the convention I've laid down, everything will work. And here we go, sorry. Don't want to scroll too fast. But everything will work as advertised. But we know when we're building applications, we're going to have to maintain them, and we're in TypeScript, so we want that type safety. So, part 2, let's adjust the slide here. Remix validated form and Zod. Remix validated form is a validation library that has a few niceties, but basically what it's doing is it's wiring up Zod that we will define server-side. I'll show you in a second. And Zod is a type-first schema declaration and validation library. I did not write that down and read that just then. Essentially what it is we can define our type in TypeScript, which is cool because we're defining a shape. Hey, this is what I want my stuff to look like. And then we're getting this validation for free, basically. And we can say, hey, does this data coming in match this shape I've defined? And with Remix validated form, I can, using a little wrapper function of theirs, I can pass that Zod information as a validator into that form. And then I get validation client side. And I don't have to think about it. I don't have to wire anything up. And it's pretty cool. And so let's have a look at that in action. So let's fire this one up. And cool. So this is Zod, and now I'm getting my validation client side. What's interesting is if I turn off JS, I disable that, I will reload the page just for all the skeptics out there. I still get it, but I don't have JS running. So how am I getting client-side validation? Well, it's using also the HTML5 attributes. And what's also interesting with Remix is it continues to work. Not all things, some things. And so it is possible with Remix to build applications that don't run JavaScript. And so if you are, say, developing for the government, that's the only case I can think these days where you might have to develop without JavaScript. Remix is actually a perfectly acceptable choice. Just remember, no client-side scripts. So everything's going to be basic and look like government forms anyway. So maybe not a big deal. But while we're here, if we do reload the page, we'll reset that. Let me clear this and I'll just quickly show you an action here. We can see that the payload is in a very obscure manner. And that's the Remix glue, joining our front end to our back end. And we don't generally have to think about this. But the back end of Remix is a Node.js app running Express and has a plugin for Express, and that's how it works. So you don't have to use the Remix backend. You can use the plugin in your existing Node Express apps. Right, well, let's have a look at Zod. Why did we add a validator? We added a validator because we like things to be valid. I mean, that's our old job, right? Make sure the input's valid. A lot of security holes are because validation errors. So we define our shape with Zod, and if you haven't used Zod before, it can be a little bit prickly to begin with, but if you know TypeScript, it kind of makes all sense. So what I do here is Zod starts with the Z. I define a discriminated union. Because I've got this action value that will discriminate on what the shape will be, I just define it as a discriminated union. And then once I define my discriminated union, I can define all the different shapes. I just need to make sure those shapes are labeled with the appropriate action. And so if we have an upsert action, I now say the shape will also have a description and an ID, but the ID is optional. This is where I put that validation, minimum 2 characters, maximum 50, and that all flowed through to the front end, and I got all that validation in my form. And so it's a fairly, I actually quite like it. I know some people don't like it, but there are other libraries out there that do the same thing in a slightly different way. So there are other options out there. Now, if we look at the action, this is where things start to get interesting because I've got my validator. Now, remember the action is running server-side, so I am using the same validator that I defined up top. I'm running that server-side, and now I get the data, and I get an error. So as that form information comes in, I know if this is valid or not now. I've got some safety around this input that I don't have control over because I have control over the website, but I don't have control over people with dev consoles. So I have to validate both sides. And so once I get past the validation part, I can be assured that the data is in a consistent form that I expect. But more importantly is I and TypeScript will narrow that. So if we're in the upsert, you will see I get those properties from the discriminated union. So now I've got type safety in my action handlers, and because we're in the completed, you'll see that I'm getting an action NID. I no longer have description because that wasn't part of the discriminated union. So I have type safety within my switch statements here. And so that has solved a bit of the problem for me. If I get my switch statement wrong, I get a type error. Perfect. But I am missing one thing at this stage, and that is if I don't declare an action handler, I don't get a type error. And we'll fix that in the third part. Oops. Undo. Perfect. So that's the validator working on the back end, on the server, and now that I've got type information from using that validator, I'm now in the safety of TypeScript, and I've got IntelliSense, and it's a lot more of a robust solution at this stage because I'm starting to get type errors. Not everything is a string. Now, if I scroll down, you will see I've swapped out my remix form with the remix validated form, and I'm passing in the validator. And that's all I had to do to get all that validation on the front end. It's taken over. It knows the shape. It's looking at the inputs, and it, it's a bit of magic, but in all honesty, probably not all that magical. But I'm not going to make it myself, and it's good enough for what I need. There still are a few problems here. We've still got some strings, so we haven't quite made it all the way, but we do have validation, and we are starting to get some type safety. And of course, everything is a validated form. I'm passing in my validator, and it's working nicely. So these are my run notes, and I have totally not been using them, so I apologize. So part 3, what can we do to make this even more type safe? It's functional. We've got some type safety in there. You might just say, that'll do, call it a day. And if I saw that, I wouldn't really mind, but we can take it a step further. And this is where the pattern part comes in. So far, I've shown you remix, Zod, remix validated form. Now they're all libraries, but this is where the pattern comes in. This is where we put a little bit of glue together to make this a whole lot better solution and to tighten up those areas where we didn't have type safety. So let's have a look at the validator. It is exactly the same. We don't need to adjust that because this is where we're defining our shape. This is the source of truth. Everything else needs to work off our Zod validator. You could twist that around if you want. Because it's a pattern, you could extract that, and I've made it sort of a dependency of the validator, but you don't have to. But if we go down now, you will see that in my action, I've got a dispatch function. And instead of doing the switch statement now, I'm required to pass in a JS object. And each action of the types I've defined in Zod need to be represented as a property of this JS object, and they need to have a handler. And why I do that is because now I've covered the last remaining hole, which is I cannot forget to define an action handler. So if I don't have an action handler, that whole route is not valid. Cool. That's the last of it. I can prove the other parts work, I promise, okay? So let's have a look at this action handler. What is it doing? And it's actually not all that complicated. There is a fair bit of TypeScript just to manipulate the types and force it into another shape. And that is probably one thing with TypeScript that can get a little bit messy where when you're doing this sort of stuff, you see all this TypeScript. And if you're not used to TypeScript, you might be like, what is that? But I promise you, the more you use TypeScript, the more this becomes second nature. But essentially, all this is doing is taking that Zod schema, extracting the discriminated union values and saying, I want those values to be a property of an object, and each one of those properties must have an action handler, which is what we saw over here. And that's all it's doing. It's just a little bit of TypeScript jumping around. You might be able to make it more simple. That's just what I came up with. And that gives me that nice shape going in, which patches that last bit of type safety. The other thing I do is just put all that form and validation into that dispatch function so that my action handlers become nice and clean. And I'm one of those people that think that if the cleaner your code is, just the more maintainable it is, because you have to read less, all that sort of stuff. So you'll see here, we've still got the validator, we've still got the form, We've got a few extra things here that aren't technically needed. This one here, the argument could be, hey, why would you be checking that if you've run it through the validator? And the reason for that is because down here I do have a little bit of uncontained script where I'm casting to any, and generally when you cast to any, you're basically saying TypeScript, thanks, but no thanks, I'm on my own here. And so that's why I have it there, just to say, hey, I can cast to any, I can do this safely because I've made sure that's all fine, and my any doesn't escape the dispatch, so I'm actually happy there to say this is type safe. Now, some people might say, you can't ever use any, and I just don't think that's realistic. So I use it, but I use any in a very controlled fashion, and I don't let it escape the bounds. So the components together are all TypeScript, and yes, there's one part where I am not being type safe, but I'm being very careful. And in return, I get this really nice dispatch that's very clean. If we compare it to the original, which has got a lot of stuff, I think that's nice. Now, if we continue down, we've still got some more untype safe things. And to fix those, we've got a few more helpers here. One, we've got use dispatch actions, and one we've got use validator fields. And if we go into the use dispatch actions, you can see I'm just creating a proxy object from the type. And I'll explain that in a sec. And the same for the validator fields. I'm creating a proxy object from the type, but I'm doing a few more TypeScript hurdles. And if you don't know what proxy objects are in JS, a colleague of mine, hang on, is he in the audience? No. Colleague of mine, Turtle. No, a colleague of mine, Tristan Menzel, has written a really good blog post on the MakerX blog site that explains proxy objects in JS. I don't know how to explain them other than they're kind of like an object that's a bit magical and you supply the magic bit. This proxy object simply says anything you say exists, I will give you back as a string. Now, normally you wouldn't say that's type safe, but the reason why it is type safe is because you can only request things to exist that are part of the type safety. So what a proxy object does in this case, if I fields, you'll see that I get the fields that I can use as part of my form elements. Even though if I did this, that would return me the string action. And I could do hello, and that would return me the string hello. But I can't do that because it's saying that's not valid when you're considering the type safety of all this, the TypeScript. And now that I have my dispatch actions and I have my fields, I can wire up these forms in a much more type-safe manner. I can say, hey, this is an action, and the value of the action is reset. And I'm using that proxy to generate those values without having to layer down those values anywhere in code. Because TypeScript type information goes away at runtime. So we have to get smart there, and we have to get creative. And the proxy objects, one way I found to do that, could potentially do with code gen, but code gen's one of those slippery slopes. And so this is my preferred method. But having done that now, we've got type safety in all our forms. And there's no more magical strings. We've cleaned up the dispatcher. Did I run this one? No. And I promise you, it works the same. It's simple to do. Nothing has really changed on the front end, but what we do now have in the back end is a type-safe solution. And if you remember back to when I was talking about the refactoring, I'm at a point now where I can change things. And if I do change things and they don't persist all the way, I will get type-safe. I will get type errors to say, hey, you're not quite there. And if you, sorry, I'm not used to touchpads. And so if I was to rename description to task, I didn't use a refactor there just to show what will happen. I can now F2 if you're a WebStorm user and on Mac. I can F2 and see all the places that potentially need to be changed. Well, they do, because we're no longer type safe. And you'll see here we're also into the fields. And so everywhere. Now, if I did a refactor action, WebStorm would actually pick up most of those. But if I started refactoring from the database, then there's a few disconnects between my types. Namely, my to-do type in the database is different to my to-do type that I've defined for the front end. And so that's when it becomes helpful, because I can start refactoring at the database level, and I can then go, right, where else do I need to, what other things do I need to change to bring it back to a valid solution? And continue on. And then because we're not in that strongly typed setting, I can't just have confidence going to refactor everywhere, but then I can keep going down that chain of like, where else do I need to refactor? What else do I need to fix? And every time the type errors go away, I'm back to a valid solution without having to run it. And that's essentially what this talk's about, building type-safe web forms on Remix. And remember, it's more of a pattern. Don't get caught up in the libraries. And I will remind everybody that all this is available on the web. You can run it in your browser, you can pull it down, run it from GitHub, and of course there's a whole blog series that covers everything I've talked about here that you can work your way through too. And that was Hook's proxy and dispatcher to the rescue, which is why when you make run notes, you should use them. And last but not least, any of those fence sitters who have made their decision, you can, if you want more content, LinkedIn. Anybody interested in art, hit me up on LinkedIn. Why are you laughing? Did you not see I sold one? To your daughter? Client confidentiality is very important to me, so I can't actually reveal that information. But the other thing is, if you visited the MakerX booth, you would have realized that we do a lot of work in the startup and venture space. We are a research and development version of that now, where we come in and we either start our own adventures. That that code you're looking at is from a MakerX product called QRX. But if you've got a startup or a venture, or if you're working in a company and you just want to have a chat, yeah, feel free to hit me up on LinkedIn. No obligations, of course. And that's where we start. Cool.
Couple of minutes, you like to take any questions, just raise your hand.
Yeah, questions?
Do you want to help with the art?
All my work, actually. Let's just go back and... yeah, that's bottom left here, that's Royce from MakerX. And the alpacas are from a talk I did, and if you're savvy enough on Google, you might be able to find that. And the sweet jump is actually from a presentation I gave to all the MakerX. Turtles, see, I have no shame, I just don't care. But if you want to buy my artwork, it's there. Sure, shoot.
All right, so I don't need the mic.
One sec, we're live streaming, so you
Oh, okay, I need the mic. So one of the things that I always thought was great about, I guess, type-safe functions and objects and all that sort of stuff is that if something doesn't exist, you need to have it. Is there a way for us to check within the HTML that a particular property is being used? Like, so for example, in our switch statement we had before, in our form would have like one action would be delete, and one would them be like, you know, upskirt and a put. But what happens if we don't? It's a bit of a silly one, but it's like when we do our refactoring, one of the things that sometimes we miss is that we deleted, let's say, a particular anchor that would submit the form as a put or whatever, right?
Yeah.
But we completely missed that because it no longer exists. Is there a way to leverage, like Zod or whatever, to make sure that those properties do exist within HTML?
Yeah, great question. So once you're in JSX and TSX, it's quite hard because you are in technically a new sort of language area. And to put type safety over all that, I think is probably possible. I just don't think it's going to be practical because you'll end up having to extract everything into very componentized parts and probably increase the maintenance cost of all of it. But it is something that's sorely missed in TSX, and I think it should be. I'm hoping, at some point in the future, as the form libraries that we use in React increase their type safety, there's a bit more pressure on React and TSX to start supporting that. I can't, off the top of my head, think of a way of how you would do that. I think it might be possible. I have to play around, but I'm pretty certain it would not be practical. Once you've got a working solution, be like, cool, we got it working, but we're not using that. That's insane. Yeah.
The only thing I can think of is like you'd have to have like a test that have to run in the background to make sure that all those components exist as a reference to something, and yeah, it would get very, very expensive.
That's right. Yeah, you could certainly cover that with testing. It would just be better if you could say, my form needs to have these inputs, and it's not valid unless it has that. That would be great. And maybe there's a cool way you could do that in TypeScript. I'm going to leave that to the form library people.
Yeah, I didn't see like 0 lines from, which is one of those things, but yeah.
Yeah.
That's a read.
No worries. Any more questions? One over here.
Can we take it later? Because it's coffee break time.
Coffee break time.
Thanks, Wade, again.
No worries.